Hi everyone, I'm Vishmi Disanayaka. Continuing from the yesterday session, today is the second day of the workshop. Today I will be discussing how to develop functions in R and also how to plot graphs by using ggplot package. Without any further delay, let's get started with the today's content. I hope you can see the R Markdown file here. As the first part of the today's session, I will be doing functions. Basically, in programming environment, function is called as a set of instructions or set of statements that we use to perform a specific task. The main purpose of developing a function is to reduce the complexity when performing an action and also to avoid repeating the same task over and over again. There are two types of functions. Those are built-in R functions and user-defined functions. So first of all, I'll discuss what is this built-in R functions. So built-in R functions are functions that are already exist in the R environment. So we don't need to build our own functions. We have R functions that are already in the R environment. So we can categorize these built-in R functions as general functions, math functions, and statistical functions. So when it comes to general functions are used to perform general actions. For an example, if we create a data frame, and after that, if we want to add a new row to the existing data frame, we use rbind. So if we want to add a new column to our existing data frame, we use cbind. So when we have a vector, when we want to sort out the vector in ascending or descending order, we use this sort function. So when we want to find the length of the vector, we use this length function. So here I have given an example. So here I have a vector called x and I have several elements there. So when I want to sort out this vector, I can just use sort x. And if I want to find the number of elements in this vector, I can use length x. So until this works, I will discuss about math functions. So math functions are functions we use to perform mathematical operations. So you know what are the mathematical operations? So here as an example, I have given several mathematical operations. So abs is used to find the absolute value of a number, and this x, or we use this to find the exponential of a number. Here sqrt, we use sqrt to find the square root of a number, and when we want to find the factorial of a number, we use this factorial function. And then we have statistical functions. So basically, statistical functions, as the name suggests, we use to perform several actions in when we are doing statistical analysis. you all know about this mean, how to find mean, variance, standard deviation, median. Likewise, so when we have a vector, we can find the mean, variance, standard deviation, and median quantized. So by just giving the function name and the relevant vector, we can find these mean, variance, standard deviation, and median values. Sorry, I think I have come across with some sort of a problem in R. I'll try to figure out what the problem here. But anyway, I will continue with the user-defined functions. So in today's session, I will be considering more on this user-defined functions, because user-defined functions are functions that the user is defining to perform whatever they want. So user-defined functions is our function created by the user applying the keyword function. So we have a set of statements. So in order to figure out whether this is a function or not, we always look for this keyword function. If a set of statements accompanied with the keyword function, then that is a user-defined function. So the main purpose of developing user-defined functions is when we want to accomplish some task, and when we don't have any inbuilt functions to perform the action, we are defining our own functions to accomplish the task. So mainly, a user-defined function involves three parts, that is the name, arguments, and the body. So here you have the basic syntax of a function. And here, in the basic syntax of defining a function, first of all, you have to give a function name. So this function name is whatever you want. You can give any name as you wish. And then with the left assignment operator, you have to have this function keyword. And then you have this argument part. So this argument part is optional. So either you can use the arguments or not, it doesn't matter. So if you're not using any arguments here, you can just keep it blank here, and then within these curly brackets, you can have the body of the function or set of statements that you need to perform the particular task. So here, I have just write a question. So here, let's see how to develop a function to add two numbers. So in here, this is the task that I want to perform. So I want to develop a function to add two numbers. So I will start by using the function name. So I have given the function name as function1, and with the left assignment operator, I have given the keyword function. So in here, I have to, if I want, I can use arguments, or else I don't need to use arguments. So here I want to develop a function to add two numbers, so that I have to give two numbers. So that I will give it as x and y. So here my x and y are the two numbers. So after that, within these curly brackets, I can perform the action what I want. So here my result should be the addition of these two numbers. So I want to return the result as x plus y. So this is the result that I want to get from this function. So this is how we develop a function. So this is a very simple function. So that let's see whether so you can see when I run the code, it didn't make any errors, no errors pop up. So that means our function is fine. So after developing the function, then we have to call the function. Developing the function is not enough. We have to know how to call a function in the R environment. So the way of calling the function is we can just give the function name. So here the function name is function underscore one. And then you can give input values for the arguments. So when I call my first function, what I developed to add two numbers, I can just give the function name, function underscore one, and then I have to give two user inputs, because since I have two arguments here, x and y, I can give two user inputs for those two arguments. Here, I will get, it will return the summation of these two numbers. So this is how we develop a function, and also we call that developed function into the R environment. As I said earlier, we can have functions without arguments also. So argument part is optional always. So here is an example for functions without arguments. So here I have defined another function, function underscore two, with the function keyword. And here I haven't given any arguments, because in here I felt that I don't need any arguments. So I didn't give any arguments. And then after that, I use several statements. So here I used a for loop. So I will be discussing these loops also. So in here, the main purpose of these two statements is that I want to print the factorial of numbers between 1 and 5. So that is what I want in this function. So so you can see no errors pop up. And when I call the function, I can just give the function name. And since I don't have any arguments here, I can just have two brackets without any using inputs. Here, I will have the factorial of numbers in between 1 and 5. So next, I will discuss once again functions with arguments. So once again, I have developed another function to find the multiplication between two numbers. So that the function name is function underscore three. And with the function keyword, I have two user arguments, A and B. And the result I want to return is A into B, or multiplication between A and B. So when I call the function, as you know, now I have to give the function name, and also I have to give two user inputs, because since there are two arguments here, I have to give two user inputs. So I will give two user inputs. So here I have got the correct answer as 24. So further, in here, the function underscore three, since I have two arguments, I can give, or I can assign a value to one of my arguments. So here, in the function development part, I have assigned one value, a user input for one of my arguments. So now B is equal to 7. So, you know, we have two arguments, A and B, but in here, B has a value and which is equals to 7. So when I call the function, you know, although I have two arguments, I have already assigned a value for one of my argument. So I don't need to give another user input. So only one user input will be enough. So when I run this, still it will give the correct answer. That means the multiplication between 8 and 7. So this is what we are learning through user-defined functions. So after that, I will quickly go through some special notes on functions. So when you want to print the arguments and corresponding default values for a function, we can have the we can call the built-in R function args. So here you have to give the function args and give the corresponding function name. So here I have given the function name as function3. So it will print the corresponding arguments and the default value for the function3. And then if I want to print the content of a function, so if I want to print the content of a function, what I can do is just type the function name. Don't add any brackets or anything, just type the function name. So if you type just function name, it will print the content of your function. And then if you want to edit a function, that means if you want to give a new name to your function, what you can do is just type the new name, what you want, and then after the left assignment operator, use the function edit. And with this edit function, give the older function name. So here, I want to change the name of my function3 as function4. So here I will give my new name, what I want. And then with the edit function, I will give my previous function name. And here, after that, I'm just calling the function. I'm just printing the content of the function to see whether I have the correct content. So when you edit the function, it will pop up a window, edit window, and here you can just click save. Then it will print the content of the function. So, so here also I have print the content of function3, and here I have the content of function4 because I have edited the name of the function3 as function4. So these are the things that I want to discuss as user-defined functions. So after that, we will be moving to control structures. So this is one of the special section or important sections in functions. So the main purpose of using control structures is control structures always allows us to put some logic into our function so that we can take the control of the function. So rather than just executing the same code each and every time, so rather than just repeatedly run the same code, we can put some logic into our function and then we can control the function whatever as we want. So there are so many control structures like if else ladder, then a for, while, repeat. Likewise, you have different control structures. So first of all, let's look at the first control structure, that is if condition. So in if condition, so here you have the basic syntax. So what happens in if condition is a task is carried out only if the test expression is true. So what happens here is with the if condition, you have a test expression. So if this test expression is true, it will carry out the task in between these two curly brackets. But if the test expression is false, nothing happens. So So in if condition, what happens is if the test expression is true, it will carry out the task. If it is false, but nothing happens. So here is an example of the if condition. So here I have assigned a new variable values and assigned some values from 1 to 10 to this new variable. And after that, by using this sample function, I am randomly picking a number from this values variable. So values have 10 numbers from 1 to 10, and out of these 10 numbers, I am randomly picking one number, and that randomly picked number is assigned as 1. And then with the if condition, I check whether this randomly picked number y is less than or equals to 5. If this number is less than or equals to 5, I want to print a statement that this number is less than or equals to 5. So let's run the code and see what are the outputs we get. So as you saw, I run the code. No errors pop up, but it didn't generate any result here. So what happens here? So actually what happens here is, we have 10 numbers. Out of these 10 numbers, we are randomly picking number. So if that randomly picked number is between 1 and 5, it will print the statement that this number is less than or equals to 5. What happens if the randomly picked number is greater than 5? Like 6, 7, 8, 9, 10. So if our randomly picked number is greater than 5, then this test expression becomes false. So when the test expression is false, nothing happens. That means no result is generated, but we don't get any errors here. So let's try whether we can have an still it's not generating because we are randomly picking a number. So here it generated a result. So here I have the result as number 2 is less than or equals to 5. So this time the randomly picked number is 2. So the randomly picked number is less than or equals to 5. Therefore, it generated or put a result as number 2 is less than or equals to 5. So this is what happens with if condition. And then after the if condition, we have this if else condition. This is a continuation of the if condition. So in here, what happens is, we have if condition and also another part called else. So this is the basic syntax. So what happens here is, if the test expression is true, it will carry out task 1. If the test expression is false, it will carry out task 2. So we have only one test expression. If the test expression is true, it will carry out task 1. If the test expression is false, it will carry out task 2. So if we take an example here, so I have created two variables, value 1 and value 2, and assigned two numbers. So what in if condition, as the test expression, I'm checking whether the value 1 is less than value 2. If value 1 is less than value 2, I want to print that value 2 is greater than value 1. So if value 1 is greater than value 2, then I want to print value 1 is greater than value 2. So since I have assigned two numbers here, let's run the code. So you see that it resulted as value 1 is greater than value 2. So in here, value 1 is 9, value 2 is 5. So when we check the test expression, you can see that value 1 is greater than value 2. So the test expression is false. Therefore, it print the statement that value 1 is greater than value 2. So I will just change this value. And then once again, I will run the code. So now you see, now you get the result as value 2 is greater than value 1. It's obvious because now the value 1 is equals to 2 and value 2 is equals to 5. So obviously value 2 is greater than value 1. So likewise, with if-else condition works like this. So in this if-else condition, you can say that if and else are in two separate lines. But there is another way we can take, that is the vector equivalent form of if-else statement. Once again, this is also the same if-else condition, but the way of writing this function is different. So here, as you see, we type if-else together, and within brackets, first of all, we write the test expression, and then we have this x and y. So what happens here is, this is the same scenario. So we are giving the test expression here. So if the test expression is true, give the result as x. And if the test expression is false, give the result as y. So this x and y are results, the expected results. So if the test expression is true, it will print the result x. It will, if the test expression is false, it will give the result as y. So here, once again, I have an example for this if-else statement. So here I have a vector called A, and I have several numbers. So I am using if-else, and here I have given my test expression. So I think you are familiar with this double percentage mark we are finding the modulus. So what happens is, we are dividing this A. This A is representing this vector. So here we are taking values from this A vector, and after dividing the number by 2, and we are checking whether the remainder is equals to 0 or not. If the remainder is equals to 0, I want to print the result as even. If the remainder is not equals to 0, that means if this test expression is false, I want to print the result as odd. So I will run the code, and here is the result. So you can see, when we divide number 5 by 2, the remainder is not equals to 0. So the result is odd. 7 divided by 2, remainder is not equals to 0. Once again, not. 2 divided by 2, remainder is equals to 0. Therefore, it will result as even. 9 divided by 2, the remainder is not equals to 0. Once again, odd. 6 divided by 2, remainder is equal to 0. So the test expression is true. Therefore, it will print as even. So this is what this is the vector equivalent form of the if-else condition. After that, we are moving to if-else statement with multiple conditions. So we are calling it as if-else ladder. So what happens here is, we have this else, we have if, else, but in between if and else, we have another function called else if. So if we compare this if-else ladder with the if-else condition, so in if-else condition, we had only one test expression. So if we had only one test expression, but in if-else ladder, what happens is, we have more than one test expression. So what happens here is, once again, we are checking the test expression. If test expression 1 is true, it will carry out task 1. If the test expression 1 is false, then it will look for the test expression 2. So once again, if the test expression 2 is true, it will carry out task 2. If the test expression 2 is false, it will carry out task 3. So likewise, we can have more any number of else if functions here, right? So as an example here, I have developed a function. I have developed my own function to find the sign of a number. So once again, the function name is sign, and I have the keyword function, and here I am giving an argument x. So I am taking a user input. After that, I'm checking whether this number is equals to 0 or not. If the number is equals to 0, I want the result as 0. If x is not equals to 0, if the test expression is false, I am going for my second test expression. And then I'm checking whether this number is less than 0. If this number is less than 0, I want my result as negative number. If this number is greater than 0, that means if the test expression is false, I want my result as a non-negative number. And after that, I want to return this result. So this is the function I have developed, find the sign of a number. And after that, I have called the function. So I have used the function name, and here I am giving a user input because I have an argument here. So let's check. Here I have given the number as 0, so it will print 0. So let's check with another number. Here, when I put a -6 here, it will print as a negative number. So if I give a positive number, it will print that this number is a non-negative number. So this is what we have to discuss under if-else condition. So when you are using if-else condition, first of all, before using the function, just identify what are the expected results. So if you have only one expected result, then you can use only if condition, because since you have only one expected result, if condition is enough. But if you have two expected result, then you have to use if else condition, because you have two expected results. But if you have more than two expected results, then you have to understand that you have to use if else ladder. That means you have to use this else if part also. Okay, so now let's move on to our other parts of the control structures, that is loops. So mainly loops allow us to execute a statement or group of statements multiple times. So when we want to run a code or run a function more than one time or multiple times repeatedly, then we use these loops. So here I'm going to discuss three loops, that are for, while, and repeat loop. And also among them, along with that, I will be discussing these two special statements, that is next and break. So we need these two statements to change the execution of the loop. So first of all, let's start with the for loop. So in here, for loop is a repetition control structure that allows you to efficiently write a loop that needs to execute a specific number of times. So when you are using a for loop, you have to understand that we can use for loop if we know the specified number of times. That means how many times we want to run this code. So if we know the number of times that we want to run this code, then we can use for loop. So here you have the basic syntax. So for I is a variable, I is taking numbers from 1 to n. So here in n is also a number. That's why I said earlier that for loop is used if we know how many times that we want to run the code. So here n should be known. N should be known. Therefore, so this loop will run from. So basically this loop will run n times. So for an example here, this is a very simple for loop. So here I have taken I from 1 to 100. So I know that I want to run this code 100 times. So since I want to run this code 100 times, I am using a for loop, and I is taking numbers from 1 to 100. And then I want to print I plus 5. So this is the task that I want to do within this loop. So if I run the code, you can see I have 100 numbers here. So this is what we expect from a for loop. So if we know the number of specified number of times that we want to run the code, we are using this for loop. And the next one is while loop. So here, what happens is a while loop is used to repeat a statement until a specific condition is met. That means we evaluate the, so this is the basic syntax. So first of all, what we are doing is we evaluate this condition, and if the condition is true, we will carry out the task that is in between this curly bracket. So this task will be carried out until this condition becomes false. That means while this condition is true, we will carry out the task. So once this condition becomes false, we will terminate, or we will exit from this loop. So for an example here, I have taken a vector called students, and I have 3 names. So here I have a count, a new variable, and I have an initial value as 3. So I have used while loop, and my condition is count is less than 10. So what happens here is, since we have an initial value for count, it checks whether the count, the value of count is less than 10 or not. So if the value of count is less than 10, it will print this vector. And then you have a special statement here. So this is what we call as increment. So increment is very important here. In a while loop, we please remember that there should be a increment. Otherwise, we will come across with an infinite loop. So I'll just explain what happens here is. So we have an initial value. So the count value is less than 10. If the condition is true, then it will print the vector, and then it the count value will have an increment. So what happens here is new count value is equals to 3 plus 1, that is 4. So once again, it will return to the first step of while loop, and once again, it will check the condition. So now our new count value is equals to 4. Still the condition is true. It will print the 3 names, and once again, it will have an increment of 1. So new count value is equals to 4 plus 1, that is 5. So likewise, this loop is continually happening until this count value is less than 10. So what happens when count value is equals to 10? So when the count value becomes 10, so you know the 10 is not less than 10. So the condition becomes false. So that is the time that we are terminating or exiting from this loop. So I will run the code, so you can see it will print the 3 names for 7 times. So what happens if we don't have an increment here? So if we don't have an increment here, so then our count value doesn't change. So so it will so you will come across with an infinite loop, because this increment is eventually meet the exit condition. So this increment is needed because it is the condition that eventually meet the exit condition. So the exit condition is this one. So after that, we are moving to repeat loop. So in repeat loop, what happens is we are just repeating the set of codes over and over again, but as if for a while loop, we are not checking any condition here. What we are just doing is we are just repeating the set of statements over and over again. So this is basically an infinite loop because we don't check any condition to exit from the loop. So in this sort of a scenario, we need those special statement, that is break, can be used inside any loop, whether it is repeat, for loop or while loop. We can use this break statement, and basically we are using this break statement to stop the iteration and flow the control outside of the loop. That means we are with the break statement, we stop the iteration and we terminate from the whole loop. So this is the basic syntax of break statement. So break statement always comes with if condition. So please remember that break statement always comes with if condition, and also we can use break with the else condition or else or if else also. But most of the time break statement comes with the condition. So here as an example, I have used the repeat loop. So I have assigned a value for a variable is set, and then initial value is 0. And I want to repeat this set of statements by I'm repeating the statements with this repeat loop. So what I am doing here is, first of all, I am printing the value of is set. So when we start with the 0, first of all, it will print the value 0. And after that, it is checking a condition. It is checking whether this Z value is equals to 6 or not. So now our value of Z is equals to 0, which is not equals to 6. Then it will just come to this part, that is, it will have an increment. So our new Z is equals to Z plus 2. That means new Z value is equals to 0 plus 2, that is 2. So once again, it will go to the first to check this condition. Still, the now our new Z value is 2 plus 2, that is 4. Once again, it will come here. It will print the value and check the condition. Still, the condition is false. Then once again, it will come to this increment part. Now the new Z value is 4 plus 2, that is equals to 6. So once again, it will go here, print the value 6 and check the condition. Now our Z value is equals to 6. Therefore, we have to execute this break statement. So what happens with this break statement is we are terminating from this whole repeat loop. So this is how we control the repeat loop. So I will run the code. And it will print the values as 0, 2, 4, and 6. So here you have 4 numbers, and although repeat loop gives you an infinite loop, with this break statement we can control the repetition. And the next statement is also another special statement we use to control the loops. So what happens with next statement is, the next statement is used to skip the current iteration and move to the next iteration. So so the difference between next and break statement is, when we use break statement, it will terminate from the whole loop. But with the next statement, what happens here is, it will not terminate from the whole loop, but just skip the current iteration and move to the next iteration. So as we like the break statement, next is also coming with the test condition. And here is an example where x is equals to 1, and I'm checking, I'm having a while condition. While this number is less than 5, we have an increment here, and we check a condition whether x is equals to 3 or not. So if the condition is false, it will print this number. And once again, so it is starting with 1. So the new x value is equals to 2. 2 is not equals to 3. Therefore, it will print 2 and come here. Once again, 2 is less than 5. So we have an increment. The new x value is equals to 2 plus 1, that is 3. So now it will come to this if condition. Now our x value is equals to 3. So x is equals to 3. This test expression is true. So we have to execute this next statement. So the execution of next statement is we will just skip this iteration and comes here. That means we are not printing the value 3. We are just once again come here and do the other statement. So once again it will check still the x is equals to 3 and we have the increment here. 3 plus 1 is 4. Now, once again, we check the condition. 4 is not equals to 3. Therefore, it will print the number. So, likewise, you can see it will print numbers 2, 4, 5, but it will not print 3 because 3 is coming with this next statement. So, these are the things that I want to discuss with the functions. So, in functions, I discussed what are the built-in R functions and what are user-defined functions and how to develop a function by using the function keyword and how to call the function into the R environment. And then I discuss these control structures. So when to use if and if else ladder, and these loops, for loop, while loop, repeat, and the two special statements, break and next. So when you're using these control structures, please remember, first of all, you have when you have a question or something like, first of all, just read the question and understand what is this asking, and just identify what is the expected result. Then only you can identify what is the correct control structure that you have to use. Without identifying the expected result, you don't know what is the control structure that you have to use to get the result. Therefore, when you are using in a practical scenario, just identify the expected result, and after identifying the expected result, you can choose what is the correct control structure to use. So now I will be moving to the second part of the workshop, that is graphs. So if you have any questions with functions, you can either put it in the chat box, or else after the graphs we will have a Q&A session, so you can ask questions in that time also. So okay. So actually, I'm a little bit rushing through the content because I don't have much time to explain each or everything. I'm sorry if I am too fast. So I will just explain graphs a little bit slowly there. So in here, as we know, we can draw graphs or plot graphs in R. Using several packages. Even without installing packages, we can draw graphs by using this plot function. But in here today, I am explaining you how to draw graphs by using ggplot2 package. So this is a special package we use to plot graphs. So in here, first of all, before using the package, first of all, you have to install the package. So when installing the package, either you can install tidyverse package or ggplot2 package. So please remember, if you install tidyverse package, you don't need to install ggplot2 once again, because ggplot2 is an embedded package in tidyverse. Because if you have installed tidyverse, you may have seen that tidyverse is a very large package. It has so many embedded packages. So ggplot2 is also an embedded package in tidyverse. So either you can install tidyverse or else you can install ggplot2 package. So after install, so I think you are familiar how to install packages in our studio. Here you have this install. So you can just type the function package name here and then you can install. So you can install any package, either tidyverse or ggplot2. After that, you have to load the package. So after installing the package, before using it to plot the graphs, you have to load the package into the R environment. So either you can load library tidyverse, the whole package, or else you can just load the needed package, that is ggplot2. So here I will load the package ggplot2. So the specialty in ggplot2 is most of the time we are using this package to plot graphs, and it is a very powerful package because with the basic commands also we can plot graphs, but with the ggplot2 we can have very attractive graphs, and also we can add a lot of elements to our graphs. So we can make our graph more attractive by adding new elements. So that is why we are using this ggplot2 package. So in ggplot2 package, a graph is made up of series of layers. So these layers are the elements that we are adding to our graph. So as layers, we can add several elements to our graph. So visual elements in ggplot2 are called geoms. So in ggplot2 we have a lot of geom functions. So these geom functions are related to different graphs. So if we want to plot a scatter plot, we have to call the function geom point. If we want to draw a histogram, then we have to use geom histogram. So likewise, you can have different graphs by using these geom functions. So these appearance and the location of these geoms are controlled by aesthetic properties. So this is one of the greatest advantage we have with this ggplot2 package. So we can control the colors, we can control the size of the points or bins. We can have many margin colors, we can have different titles, and even in the titles we can have different font colors, different fonts. So likewise we can do a lot of things by using this ggplot2 package. So then we have variables that we want to plot is referred as aesthetic. So this AES is referred to aesthetic. So even when we are plotting a graph manually, we have two axes, that is X and Y. So in ggplot2 also we need to identify what is the x-axis, what is the y-axis, and then we have to define those x and y here. So those x and y are defined in this aesthetic function. So the basic syntax of ggplot plot is the ggplot function, and here first of all we give the data set name, and then after that we are using this aesthetic function. So on the aesthetic function, we name what is our x-axis, what is our y-axis. So this x and y are related to the column names of the data set. So here x and y are the column names of this data set. And after that, we are adding a layer. So this is how we add a layer. With the plus sign, we can add different layers to our graph. So after that we are adding a layer which is geom function. So by using different geom functions, we can create different graphs. So let's start with the scatter plot. So scatter plot is used to observe and show relationship between two numerical variables. So most of the time we are plotting a scatter plot to identify the relationship between two numerical variables. So for an example, when we want to identify the correlation between two variables, what we do is the first step is we are plotting a scatter plot for these two variables. Then only we can identify whether there is a relationship between those two variables and whether that relationship is positive or negative. So that is the main intention of plotting a scatter plot. So let's start with the scatter plot. So first of all, I am loading a data set called mSleep. So this mSleep data set can be found in the ggplot2 package. So before start plotting any graph, you have to load the package this library ggplot2. After that, you can have this data set, that is mSleep, and with this head function, we are printing the first 8 rows of the data set. So here you have the first 8 rows of the mSleep data set. So here you have different columns. So I will just explain this as a question. So now we are asked, how do we plot body weight against sleep total in a scatter plot using ggplot2 package in RStudio? So now we are asked to plot a scatter plot for this body weight. This is the body weight column, and the sleep total. This is the sleep total. So you can see these two columns are numerical. So we have to have numerical variables to plot the scatter plot. So now let's start plotting a scatter plot for this body weight and sleep total. So here I started with giving a name for this my scatter plot. Either you can give a name or not, it doesn't matter. So I am giving a name as scatter plot 1. And after the left assignment operator, I am starting with the ggplot function. So after the ggplot function, first of all, data is equal. So first of all, I have to give the name of the data set. So here my data set is mSleep. And after that, under aesthetic condition, I have to give what is my x-axis, what is my y-axis. So here, when we are plotting a scatter plot, and since we don't have any clue to select what is the x-axis, what is the y-axis, you can give any. So here, I will just give x is equals to body weight. So here, this name is the column name of this data set, right? And y is, I will take it as sleep total. So now I have given the data set name, and under aesthetic, I have given what is my y-axis. So y-axis should be the body weight, and x-axis should be the body weight, and y-axis should be the sleep total. And after that, I am adding the geom function. So here I want to plot a scatter plot. Therefore, my geom function is geom point. So here you can see this is the basic scatter plot of body weight and sleep total. So here you can see the dots, and here this is the column names that I've used for the x-axis and the y-axis. And now let's add some other layers and make this scatter plot more attractive. So since you can see the dots are in black color, if I want to give a color for these dots, a different color, so in here, sleep, you can just give data, and within quotations you can give the dataset name sleep. But remember that sleep is embedded in the ggplot2 package. So first of all, you have to load the ggplot2 package. After that, you can load this sleep package, sleep dataset, and this head function is we are using to print the first 8 rows. Here I am giving 8. It has 8, so you can either give any number. So it will print the first 8 rows, right? So here, if I want to give a color for these dots, I will use the function call. Call equals, and I will give any name color. So here I am giving blue color. So call is equals to blue. And then you can see the color of the dots has become blue. This is how we assign a color for the dots. That is by using this call. And if I want to change the size of these dots, what I have to do is, so please remember, when you're adding a color, it should be in this geom point function, right? Inside this geom point function. So if I want to change the size of these dots, I will just give size equals, and here I am giving 3, and let's see. So you can see now the size of the points has become larger. So after that, so you know that you have these are the column names of this our data set, but we want to have proper x-axis label and y-axis label. Then how to add x-axis label and y-axis label? So once again, we are adding a layer called xlab. So this xlab is refers to the x label. So my x label is body weight. And then I want to add another layer, that is y lab. So y lab is refers to the y label, and then I am giving task sleep total. So if I run this one, now you can see I have proper x-axis name and y-axis name here. So after that, if I want to add a title for this graph, so then what, I can add another layer called GG title. So under GG title, you can give a proper name to this graph. So I'm just giving a title name as sleep data. So here you can see I have got the title of this graph. So here, so what we did was we gave a color to these points. We changed the size of the points by using this size function, and then we can give specific names for x-axis and y-axis by using xlab and ylab, and then we can give a title for our data graph as from GG title. So this is about scatter plot. Hope this is clear for all of you. So now let's move on to histograms. So basically, you know, histograms are we are plotting histograms to graphically summarize the distribution of a variable. So you know, we are using histograms to see to graphically see the distribution of the a numerical variable. So in order to find this one, here I have created a data set. So by using the set seed, and my data set name is weight data. And here I have two columns as sex and weight. The sex is having two factors, that is male and female, and I have weight, different weight for these factors. And after that, I am printing the first 5 or 10 rows of my head weight data. So here you can say this is something that I have created. So this is something what I have created. So here I have the column sex and the weight. So now what by what I want to do is I want to plot the weight in histogram by using a ggplot. So I want to figure out the distribution of weight data in my data set. So in that sort of a scenario, we have to use a histogram. So once again, we are starting with the ggplot function. Here, the same scenario, ggplot, and as the data, first of all, we have to give the data set name. So here, my data set name is weight data. And then after that, I have to clearly define what is my x-axis and y-axis. So in a histogram, you know, yes, so in scatterplot also we can draw different scatterplots. That's why we are using this plus sign. So by using a plus sign, we can draw different types of scatterplots in the same graph, and also we can add different colors to these scatterplots, right? So in here, histogram. So when we are plotting a histogram, you know that our y-axis is obviously the frequency or the count. So here we don't need to define what is our y-axis, because obviously y-axis is the frequency, because it is plotting the frequency of these numbers. So we don't need to tell what is our y-axis. We just want to tell them what is our x-axis. So our x-axis should be this weight column, because we want to graphically find out the distribution of this weight column. So our x-axis would be the weight. And after that, my geom function, now I want to draw a histogram. Therefore, now my geom function becomes geom histogram. And if I run the code here, this is the basic histogram. So you can see here you have the count. So because that's why I told you that we don't need to tell what is the y-axis, because the y-axis is obviously the count. Here, this is the weight, and here you can see the distribution of the weight data. So now, as you can see, we can change this bin width. So width is bin width is the width of these columns. So we can change this bin width. So how to change the bin width? Once again, inside geom histogram, we can use the function bin width, and then you can give any number as bin width. So here I will just give 5. So now you can see my bin width has increased. So if I change this bin width into 1, once again, my bin width has changed. So now the bin width of my columns is 1. So after that, so if I want to give a color to these bars, that means since it is in gray color, if I want to give a color to this bars, I can just use fill. Fill equals, once again, I will just give pink. So please remember that all of these are under the geom histogram function. Now you can see I have a pink color graph because now I have colored all these bars in pink color. So after that, but still you can see that although you have added color to these bars, you can't clearly figure out the margins. So you can add a separate color for the margins. So how to add the margin color? So inside this geom histogram, you can use the function color, color, color equals, and you can give any color. So now you can see, you can clearly see the margins of these columns. So if you want to add a color to the columns, you have to use fill. If you want to add margin colors, you can use this color function. And after that, we can change these line types also. That means we can change these margin line types. So how to change this margin line types? Once again, inside geom histogram, you can type line type. Line type equals, and you can give any line type. So here I give it as dashed. Now you can see my margin line type has converted to a dashed one. So sometimes you may curious about how to so what are these line types? So can we have other line types? So if you want to know what are the other line types, what you can just do is just in the console of the R Studio and just type this question mark and then type line type. If you press it, then under the help window, you will get the description of this line type. So in here, if you go through this description here, you can see what are the line types available here. So here 0 is equals to blank, 1 is equals to solid, 2 is equals to dash. So you can figure out what are the line types available in ggplot. So in here, as the line type, either you can use these numbers or else you can type these words. So that's how you can find what are the line types available in this ggplot package. So this is how we draw a histogram. And in ggplot package, there is another way of drawing histograms, but we are not using it because this is not very popular one, and also we can't add these type of elements to our graphs by using this function. Another way of creating histogram by using ggplot2 package is this qplot. So what happens with qplot is, first of all, qplot, and we give the corresponding x-axis. So here in ggplot, so here this is the equivalent form of the ggplot. So in ggplot, first of all, we give the data set name. But in qplot, first of all, we give what is our x-axis. And after that, we give what is our data set. And then under geom, this is the special function in qplot. So under geom, we give geom is equals to histogram. And then this bin width is once again like the width of the bin. So it is same as the ggplot. But in here, we have to clearly state that geom is equals to histogram. So in qplot, we have only two folds, that is either to plot a histogram or a scatter plot. So if we only specify x variable, that means if we only specify x variable here, then geom is obviously a histogram. If we specify x and y both in here, then geom is equals to point. That's how we figure out whether this is a scatter plot or histogram. So that is about qplot, but actually we are not using this one because we can't add this sort of elements to histograms when we are plotting from this qplot. So this is just for your reference. So this is the plot we get from the qplot. So you can see you have only this x-axis name, but you don't have any y-axis name here. So this is the equivalent graph from the ggplot. So in ggplot, you can see you have these axis names, and so this is the qplot graph, and this is the ggplot graph. So qplot is an optional one, but so this is that is only for your reference. So you can use geom histogram to draw the histograms by using ggplot2 package. After that, we are moving to box plots. So as you know, box plot is used to check how well data is distributed in our data set. So obviously, by using the box plot, we can identify the minimum value, maximum value, the median, first quantile, third quantile. Likewise, we can have a clear idea about our variables by using box plot. And also we can find the outliers, whether we have outliers or not. That's how we identify whether we have outliers by using a box plot. So first of all, I'll explain it by using a example. So first of all, I am loading a data set called air quality, and here I will print the first 10 rows of the air quality data set, that is the head, by using this head function. And after that, this str is refers to the structure of the data set. So by using this structure, I want to figure out what are the types of variables in our data set. So here, these are the first 10 rows of the air quality data set. And here you have the structure of the data set. So you can see these are the column names and these are the type of the variables. So you can see all are integers and numerical values are there. So in here, the question is asking you how to make a box plot for ozone readings for each month separately using ggplot2 package in RStudio. So what we have to do is we have to plot for ozone reading. So ozone reading is in here. So we have to draw box plots for ozone reading month-wise. So we have to first of all separate these ozone readings according to month, and then we have to draw separate box plots for each month. So what happens here is, although we have to categorize these ozone readings according to month-wise, you can see month has become an integer value here. So it is numerical. But if you want to divide or categorize these ozone readings and plot it separately, then your month variable should be a categorical variable. It should be a categorical variable, not a numerical variable. So, but in the data set, you can see our month variable is still a numerical variable. So as the first step, what we are doing is we are converting the month into a factor variable. Factor means into categories. So how to convert it into factor variable? Once again, we are referring to the corresponding column, that is month, and then we are converted into a categorical variable or factor by using this factor key. By giving the factor function, then once again we are giving the corresponding column, quality $sign month, and after that we are giving some labels. That means here you can see you have integer values 5, 6, 7, 8, 9. Likewise, you have the month is represented by numerical values. But here we have changed that numerical values into strings. That means May, June, July, August, and September. So if I run the code, and if I once again use this str to find the structure of the array. So after converting month into categorical variable, you can see now it has become a factor variable, and it shows that there are 5 levels as May, June, July, August, September. So now you have a factor variable or a categorical variable. Now you can start plotting a box plot for the ozone readings. So once again, we are starting with the ggplot function, ggplot, and first of all, we have to give the dataset name. So our dataset name is air quality. And after that, we have to give what is our x-axis and what is our y-axis. So you know we are asked to plot the ozone reading against each month. So our x-axis becomes month and our y-axis becomes ozone. So please remember these are the column names of this data set. So our x-axis is the month and y-axis is the ozone. And after that, you know that we are doing a box plot. Therefore, now our geom function is becoming geom box plot. And if I run the code, here you can see I have got a box plot for the ozone readings for each month. Here we have May, June, July, August, September, 5 different box plots, and here these dots are referred to the outliers. So this is the basic box plot. After that, so now let's see how we can add different elements to this box plot. So if I want to give a color for this box plot, same color for all these boxes, then I can use once again inside geom box plot fill is equals to, I will give red. So here now by using fill is equals to red, I have given a single color for each of these box plots. So if I want to give a color for these margins, so you can see these margins. So if I want to give a color for these margins, once again, I can use the function color. Color equals, and I will give like green. So now you can see, now the margin colors has changed to green color. So after that, you know, these are the outliers. So if you want to give a separate color for these outliers, so if you want to give a separate color for these outliers, what you can do is inside geom box plot, you can type outlier dot color. And if you inside our outlier color, you can give any color. So I am giving it as purple. And now you can see now outlier colors has a different color. So now my outliers are in purple color. So if you want to change the shape of these outliers, what you can do is you can type outlier dot shape, and then you can give any number. So by changing the values, you can get different shapes for these outliers. So if I give it as 5, then I have a different shape for my outliers. So you can, as I showed you earlier, you can check these shapes by typing this outlier shape in the console. So after that, we can give a x-axis name and a y-axis name. So as we did earlier, how we are having the same procedure. So if you want to add a x label or x-axis name, once again x lab, and then you can give any name. And if you want to add a y-axis name, once you have to use y lab, and then give any name as I'm giving mean ozone concentration. And if you want to add a title, so it is the same way. You have to use GG title and then add a so likewise, you can create different, you can add different elements to your box plot. Now, most of the time, when we are plotting different box plots, we are not assigning the same color for each and every box plot. So we always want to have different colors for these box plots. So for that, if you want to have different colors for the box plot, first of all, then you have to remove this fill color, because by using fill color, we are giving a single color for each and every box plot. So if you want to add a different color, then you have to change, remove it. And then in ggplot function under aesthetic, we are giving x-axis, y-axis, and also we are giving another one that is called fill. And under fill, we are giving it as month. So what happens here is we are conveying that we are going to add different colors according to the month. So under ggplot function, we in aesthetic function, we are giving this fill is equals to month. So what this means is we are conveying that we are gonna add different colors for this box plot. So after that, you can manually assign different colors for box plot. So how to manually add different colors is, once again with the plus sign, you can use scale, fill, manual, and then you have to give values equals, and as a vector you can give any 5. So since we have 5 box plots, I can give 5 names, 5 colors as the manual colors. So I will just give some colors here. I have just given 5 names. So now you can see I have different colors for my box plots, and also ggplot2 package automatically generate a legend for these colors. So when you are using the basic commands, you have to manually add a legend when you develop plot the graph. But in ggplot2, what happens is it automatically create a legend for you. So after that, having this legend, so if you want to change the position of this legend, then what you have to do is you have to once again add a layer called theme, and under theme you can use legend dot position, and then you can give any position. So I think I want to change the position. I want to have my legend at the top of the graph. So I will use it as top. Then you can see I have my legend at the top of the graph. So this is how we are plotting the box plots. So after that, we are moving to the bar chart. So bar chart is basically we are used to compare variables. So in a ggplot2, bar chart has two forms. So one is we are plotting the counts of each category, and the other fold is the typical bar plot, where all these categories have specific values, and those specific values are plotted in the bar chart. So since bar chart has two folds, I will discuss both the folds. So first of all, I'll show you how to plot the counts in a bar chart. So once again, for that, I'm loading another data set called empty cars, and here I have the I am printing the first 10 rows, and also I'm looking at the structure of the data set. So this is the first 10 rows of the empty cars, and here this is the structure of the data set. And after that, the question is how to create a bar chart for cylinder using ggplot2 package in RStudio. So cylinder refers to this one. So in cylinder, you can see it is a numerical variable, but it has three categories as 4, 6, and 8. So now what we are going to do is we are plotting how many times 6 appears in here, how many times 4 appears here, how many times 8 appears here. That means we are counting how many 6s, how many 4s, how many 8s are there in this column, and we are representing those counts in the bar chart. But for that, although this is a numerical variable, when it comes to when we are plotting a bar graph, our x-axis should be a categorical variable. So for that, what we are doing here is we are converting our cylinder variable, that means this numerical variable, into a factor variable. So how to convert it into a factor variable? We use this function as.factor. So once again, in the ggplot function, here I give my dataset name. So my dataset name is empty cars, and under aesthetic, so we are in here we are plotting the counts. So y-axis is obviously count, so you don't need to clearly define what is the y-axis because it is obviously the count. So you have to define what is x-axis. X-axis is cylinder, but cylinder should be a categorical variable. But in here, you can see it is a numerical variable. Therefore, we are using as.factor to convert the cylinder variable into a factor variable. And after that, in order to develop this bar chart, we are using this geom_bar function. So if we plot, you can see here we have the count. Here we have the three categories, 4, 6, 8. And here we have the x-axis name. So now, if you want to add different colors, if you want to add colors for these bars, you can once again use fill equals. And here in ggplot2, we have different color patterns, rainbow colors, heat colors. Likewise, we have different color patterns. So here I am using heat colors. So under heat colors, you have to specify how many heat colors you are using. So since here I need only 3 colors here, I will give 3 here. So you can see I have 3 different colors for my 3 bars. And then if I want to add a margin color, then I have to use this color function, and then I can give any color. So these are the margin colors. And if I want to change the width, then I can use width equals, and so width is in between 0 and 1. So you can give any width. It is as you wish. You can see I have changed the width. And so here also you can give X label and Y label. You can use a title by using GG title. And also you can give colors by using color palettes. So in ggplot2 we have color palettes. So these color palettes are not these heat colors. Those are special color palettes. So if you want to add a color palette, once again what you have to do is you have to remove this fill colors in here, and then under aesthetic you have to mention that you are assigning different colors to these three columns, and then after that you have to use this scale fill beaver. And then you can use palette equals, you have different palettes here. So you can see I have assigned different colors by using this color palettes, and here I have a legend also created. So if you want to find out what are the color palettes, once again you can use this question mark and type scale fill brewer. So if you type scale fill brewer, then here under the help window you will have the description for this color palettes, and here you can see the color palettes, and these are the color palettes available in ggplot2. So here I use dark 2 color palette, but you can use any sort of color palettes. So in here, sometimes we are plotting a bar. We need these bars horizontally. So these vertical bars, if you want to convert it into horizontal, then what you have to use is you have to use chord flip. So if you use chord flip, then your horizontal, you will have horizontal bars like this. So you can take this by using this chord flip. So this is how we plot the counts, and then I will discuss you how to plot, how to get the typical bar plot. So in a typical bar plot, so I have created a data set called data. Here I have different names A, B, C, D, E, and different values. So basically we are plotting a bar chart to for these values, and we compare these categories. So when we want to plot a graph for these categories, these values, once again, we are using the same function ggplot2, and we give the data set name, and under aesthetic here, you know that our x-axis becomes the name and y-axis should represent these values. So this y is equals to this column, and under geom bar, we have a special function called stat. If you want to plot a bar chart where each of these categories have specific values, then you have to use this stat function. So here stat is equals to identity. If you give it as stat equals identity, it will plot these specific values. So this is something that you have to keep in mind, that if you are plotting specific values in a bar chart, then you have to give stat is equals to identity. Otherwise, if you are just plotting the counts of each category, then you don't need this stat function. So if you want to have specific values, if you are plotting a specific value, then you have to give stat equals identity. So after that, we are moving to the last part, that is the pie chart. So pie chart is basically we are displaying the data in a circular graph. So each slice of the pie is relative to the size of the category. So let's see how to draw a pie chart. So first of all, I have created the data frame here, subjects and the count. So now I want to represent these counts in a pie chart. So how to represent these count values in a pie chart? So first of all, I will start like this. So in here, once again, start with the ggplot and give the dataset name. So my dataset name is data here. That's why I am giving the dataset name. And under is static. In here, in a pie chart, we don't have any x-axis because obviously we are plotting these subjects. So each slide we have different slices for these subjects. Therefore, we don't need to specify what is our x-axis because obviously we are plotting the graph for these subjects. Therefore, we don't need any x-axis. That's why you have to give it as two quotations and keep it blank. And as our y-axis, we are plotting our counts. So y is equals to this count variable. And then we give fill is equals to subject. So as we did earlier, this fill is equals to subject conveys that we are going to have different colors for different subjects. That means these subjects will have different colors. So in order to convey that, we use this fill is equals to subject. After that, first of all, what we are doing is we are plotting a bar graph. So that is why we are using this geom bar. So under geom bar, I have used status identity because here we are plotting these specific values. So physics have a specific value and it is 27. English has a specific value that is 35. So we are plotting these specific values. Therefore, under geom bar, you have to give status identity and width is 1. So width is 1 is refers to the column width. So let's see what sort of a graph we have. So you can see we have this sort of a bar chart. Here it shows the count. So this count is refers to this variable. Here the variable name is count. So that is what is referring here. And we have a single column. And this sort of a graph, we call it as stacked bar chart. Here, all the slices are stacked on one another. And this is called a stacked bar chart. So now what we are doing is, after creating this stacked bar chart, we are converting these linear coordinates into polar coordinates. So how to convert it into polar coordinates is we use this specific function called polar. So after creating the bar graph, we are converting these linear coordinates into polar coordinates. So how to convert it? It is by using this chord polar. And after chord polar, you have a variable here. It is called theta. So this theta variable is refers. So here my theta variable is equals to y. So what is this theta? So theta variable refers to the variable that we use to map the angles. So as you know, in our pie chart, we are mapping this count. This count variable is mapped as the angles. So these counts are representing the corresponding angles. So here, this y is refers to this one. So here, as theta, you have only two options. Either you had to use x or y. So, but in here, our x is blank, but we are plotting the angles by using according to this count values. Therefore, our theta is equals to y, and our starting position is 0. So this is what the basic pie chart looks like. And all these things are mandatory when you are plotting a pie chart. So without this geom bar, you can't use this chord polar, right? First of all, you have to have this GG plot and this geom bar. And after creating the geom bar, we have to use this chord polar, because what we are doing here is we are changing these linear coordinates into polar coordinates. So now what happens here, you can see this is the basic pie chart. So we have the corresponding legend, and here we have the polar coordinates, and this is the starting position 0. So this is the basic pie chart. So after that, most of the time, the extension of this pie chart is we need to have we are pasting the slice percentages here. Actually, calculating slice percentage, I will describe it here, but I don't think whether you will understand that one, because it is little bit confusing at all, but I'll just explain what is happening. Okay. So in order to calculate these slice percentages, we need another package called dplyr. So this dplyr package is only needed for the calculating these percentages value. So in order to draw the graph, we don't need this dplyr package. So dplyr package is only needed for data manipulation. So first of all, we will load the dplyr package, and after that, step by step, we are calculating the slice percentages. So first of all, I'll just comment this one. And first, what I am doing is I am arranging my data set according to the descending order of the subject. So I will just run this one and show you the result. So here, now as the first step, what I have done is I have arranged my data set, the subject names according to the descending order of the alphabet. So when you are arranging it into descending order, obviously it is coming in this order. So after that, what we are doing is we are adding a new column called proportion, and we calculate the corresponding proportion for each count. So how to calculate the proportion? We take the summation of all these counts, and we divide these specific counts from the total count, and we multiply it by 100 to take the percentage. So here, now what has happened is so this mutate function is used to add a new column to this existing data frame. So the new column is proportion, and we have calculated the proportion or the percentage for each of these counts. And after that, what we are doing is we are finding the cumulative proportion. So now what happens here is, after calculating the proportion, we are finding this y position. So y position is refers to this data label. So this is the percentage or the corresponding percentage of these subjects, and this y position is refers to the label position in the pie chart. So this is the label position in the pie chart. So So calculating the y position is done like this. I don't know whether you will understand this one. First of all, we get the cumulative sum, and then we take we subtract half of the proportion, and that's how we are finding the y position. So sometimes this may be confusing, but when you are learning pie charts, you will figure out how to find the y position here. So first of all, we have to find the corresponding proportions and the label positions. So after that, we can create the pie chart. So once again, we are starting with the GG plot. And now my data set is here. And this is the data set name. And once again, the aesthetic is X is blank and Y is proportion. Now we are creating the pie chart according to the proportion, and we are assigning different colors according to the subject. And first of all, we have to create the geom bar or the bar chart, and after that we are using this chord polar to convert the linear coordinates into polar coordinates. And after that we are using this theme void. So theme void is used to remove this polar coordinates. So you can see this 0, 120, 30, 60, 90. So in order to remove these polar coordinates, we use this theme void. And after that, we use this theme to change the legend position. So now I have changed the legend position into left side. And after that, geom text is used for the slice percentage. Geom text is used to represent the slice percentages. So once again, in here, under geom text, the aesthetic, the y is equals to this y position. This is the label position. And label is equals to, first of all, we are rounding off this one proportion into second decimal place, and we are pasting the percentage mark, and the label is in white color, and the size of the label is 3. And I have used the color palettes to assign colors. So if I run the code, this is the corresponding pie chart, and you can see you have the labels in the middle of each slides. So this is what I want to discuss under graphs. So in here we discussed how to draw scatter plots, histograms, box plots, true false in the bar graph, and also pie chart. So you will be learning these things in first years. Will be learning these things in the first year under ST 104, and others. I think you get some kind of idea in here. So I think I bit rushed through the content. Hope you get an idea on that. So I think now we can start the Q&A session.